Did you know that water at 60 degrees Celsius can induce scalding injuries in less than 3 seconds? On the other hand, temperatures in a relaxing sauna can be well over 65 degrees Celsius. Why does water at 60 degrees hurt so much more compared to a sauna at more than 65 degrees? The answer lies in the science of specific heat capacity. First, we need to talk about what makes things hot or cold. Everything that we can see and touch is called matter. Matter is made up of extremely tiny particles called molecules. These molecules are moving at random speeds in random directions. Molecules at a higher speed will have a higher amount of kinetic energy. Kinetic energy is given by this formula. The kinetic energy can be increased by increasing the mass or the speed of the molecules. The kinetic energy of the molecules is an important concept to keep in mind when talking about heat and temperature. Even though heat and temperature are closely related, they are not the same thing. Temperature tells us how hot or cold a substance is. Temperature is the average kinetic energy of the molecules in a substance. Some molecules may be traveling faster than other molecules, and those faster molecules have more kinetic energy. But we need to calculate the average kinetic energy to measure the temperature. When molecules in a substance have high average kinetic energy, then substances also have a high temperature. Temperature is measured in degrees Celsius. On the other hand, heat is the total amount of kinetic energy in the substance. We need to add up the kinetic energies of all the molecules to obtain the amount of heat energy in the substance. Heat can be transferred to a substance to increase the total amount of kinetic energy, which will increase the average kinetic energy of each molecule, which will increase the temperature of the substance. However, the amount of heat energy needed to increase the temperature of an object depends on the material and the mass of the object. Heat energy and temperature can be related using specific heat capacity. The specific heat capacity is defined as the amount of heat energy required to increase the temperature of 1 kilogram of substance by 1 degree Celsius. Different materials have different molecules with different interactions between the molecules, so different materials have different specific heat capacities. For example, water has a higher specific heat capacity than oil. So, for the same mass of water and oil, more heat is needed to increase the temperature of water. Additionally, the amount of substance also matters. More heat energy is needed to increase the temperature of 100 kilograms of water than for just 1 kilogram of water. Water has a specific heat capacity of 4184 joules per kilogram per degree Celsius. This means that we need to add 4184 joules of heat energy to increase the temperature of 1 kilogram of water by 1 degree Celsius. For 2 kilograms of water, we need to double the amount of heat energy. To increase the temperature by 3 degrees Celsius, we need to triple the amount of heat energy. Here's the equation to understand this better. Q is the heat energy, M is the mass, C is the specific heat capacity, and T is the temperature change. The specific heat capacity of water is 4184. Let's say that we have 10 kilograms of water and we need to increase its temperature from 25 degrees Celsius to 55 degrees Celsius, which is an increase of 30 degrees Celsius. So, after doing the math, we find out that we would need about 1.3 million joules of heat energy to do that. Hence, we can see that more heat energy is needed to heat up more water to a higher temperature. More fuel is needed to provide that additional heat energy. So, why does water at 60 degrees Celsius hurt us so much, but a sauna at more than 65 degrees Celsius feel comforting? The specific heat capacity of water is 4184 joules per kilogram per degree Celsius, which is really high compared to other substances. When your skin, which has a temperature of about 33 degrees Celsius, touches water at 60 degrees Celsius, heat energy flows from water to your skin. Water holds a lot of heat energy, which flows into your skin and it causes proteins in your hand to vibrate very fast. Proteins in your hand begin to denature and fall apart, which will lead to injury. Pain receptors in your hand can detect that and they begin to fire pain signals to your brain. On the other hand, in a sauna, hot air is in contact with your skin, and the specific heat capacity of air is just 1005 joules per kilogram per degree Celsius. Far less heat energy is transferred from the hot air to your skin, and proteins in your hand aren't denatured, and there is no pain. Now we know that the temperature of a substance does not tell us everything, and we also need the specific heat capacity. There is a huge difference between a 65 degrees Celsius sauna and a 65 degrees Celsius swimming pool. One is a relaxing experience, and the other is a very painful death.